Hello and welcome to a lesson on fractions and decimals. So we're basically going to be looking at how to write fractions and decimals and how to compare fractions and decimals to close out our chapter. To write a fraction as a decimal, we're going to interpret the fraction bar as a way we've interpreted it before. We're going to interpret it to mean division. That's exactly what that fraction bar means. It's division, and we're going to find the quotient. So we're just going to take our numerator and divide by our denominator. We've done this before, but we ended up with whole number amounts. And not decimal amounts. So a process we've seen just in a new situation. So for example, 1/4, if we wanted to convert that to a decimal, we would just divide. So our numerator of 1 is our dividend, and that is a giant eraser. Our numerator of 1 is our dividend, and our denominator of 4 is our divisor. So obviously 4 is not going to go into 1, so what we're going to have to do in cases like this is add our decimal point after the ones place and put some zeros in there so that we can do this division. Now I don't know how many zeros I'm going to need. I may not need all those, but they're there if I need them. So the decimal in our answer is going to be right above where it is in our dividend. And again, 4 is not going to go into 1, but it will go into 10. So since we're going into this place, that's where our answer has to be. So it's going to go into 10 twice, and 2 times 4 is going to make 8. We're going to subtract from 10 to have 2 left, and we don't want that remainder, so we're going to bring down a 0. And 4 goes into 20 exactly 5 times. 5 times 4 is 20. So no remainder means we can stop. So 1/4 is exactly 0.25 as a decimal. Okay? And if you wanted to go backwards and try to confirm that, think about 25 in the hundredth place of the fraction. 25 over 100 if we were to reduce by dividing by not dividing by 4, sorry, by dividing by 25. 25 is going to go into 25 once, and it's going to go into 100 4 times. So there you have it. Okay, there's 0.25 as our decimal. And I went a little crazy with my eraser. Okay, so let's look at another one here. This time 2/3. And actually, a couple of these, like the 1/4 and the 2/3, these are kind of common decimals. It'd be really helpful to common fractions are really helpful to know their decimal amounts. So our dividend, 2, our numerator, is being divided by our denominator, which is our divisor of 3. Again, 2 is not going to go into 3, so I'm going to add my decimal and some zeros if I need those. And decimal in my answer will be right here. So 3 is not going to go into 2, we're going to go into 20, so we're looking for that place value there. And 3 goes into 20 6 times. 6 times 3 is going to make 18. We're going to subtract and have 2 left over. If I bring down a 0, 3 is going to go into 20 again 6 times, and that's going to make 18, and that's going to give me 2, and I can bring down a 0 and keep doing this as many times as I want, but that pattern is going to continue, which means this 2/3 is going to be equal to 0.6 repeating, and we'll put the bar over the 6 to show that that is a repeating decimal. Okay, let's try another one. I'm going to look at another common fraction here. Maybe you recognize this one. Here we're dividing 7 into 22. Notice this time we have an improper fraction. Proper fractions will have decimal parts but no whole number parts. If we have an improper fraction, we should have a whole number part and a decimal part. Okay, so here again our numerator is our dividend that goes inside the box, that's 22. Our denominator is our divisor, it goes outside the box, that's 7. And I'm going to go ahead and add my decimal and some zeros here. So 7's actually going to go, decimal's going to go here. 7's actually going to go into 22 3 times. So that's 21 with 1 left over. Bring down the 0. 7's going to go into 10 once. Excuse me, 1 times 7 is 7. So we're going to have 3 left over. Bring down the 0. 7's going to go into 34 times. That makes 28. 2 left over. 7's going to go into 24. Sorry, not 4 times. 2 times, oh my gosh, I'm choking and I can't focus. 7 times 4, or 2 times 7 makes 14. And then I'm going to have 6 left over. And I could put on another 0. And bringing down another 0. 7 is going to go into 68 times. That's going to make 56. Then I'm going to have 4 left over. And I could keep going. It looks like I'm going to be able to keep going. And so far I don't see a pattern in any of these remainders like I did in the last one. So I'm going to put a dot, dot, dot again here. This dot, dot, dot meaning that this decimal is going to continue. And if that number looks familiar, I'm glad. 3.14 is approximately our value for something we call pi. If you've heard of pi before, that's something that we use a lot in geometry. And pi is, in fact, a non-repeating, non-terminating decimal. It's a decimal that goes on forever without any pattern in its digits. And sometimes we use a fraction of 22 over 7 to try to approximate or get close to our value of pi. Okay, so that's not crucial for you to know, but helpful and a nice to know information. So where do we stop this? Well, it would depend on the situation. So if I asked you to approximate a decimal for 22 over 7 and I said rounded to I don't know, let's say if I said round to the nearest, let's say 10th. If I said round to the nearest 10th, the 10th place is here. After it is a 4, which means that the 1 would stay. So rounded to the nearest 10th, we would say it's approximately 3.1. If I said round to the nearest 100th place, to the nearest hundredths, well, this is the hundredths place. After the hundredths place is a 2, so again that would stay. So we would say that it's approximately 3.14. If I said around to the nearest thousandth, this is the thousandths place, and after it is an 8, so that 2 would round up. So we would say it's approximately 3.143. So it just depends on where you're asked to round, okay? So if you're asked to round to the 10th, then stop when you get to the hundredths. If you're asked to round to the hundredths, stop when you get to the thousandths. And if you need to go to the 10,000ths, you need to go 1 decimal place past where you're asked to round if your decimal keeps going, okay? Now, in this next one, we have a mixed number. So you've got 2 options when it's a mixed number. You can take your fraction part and just do the division there. Let me show you. So if I do the division, let's say 16 is going to go into 3. Let's add some zeros. And it's going to go into 30 once. There's going to be 14 left over. It's going to go into 14. I don't know, 7. Let's see. That's 42, 112. Nope. And there's 28. Okay, I think it's got to be 8 times. So let's put an 8 here. 8 times 6 is 48. So we'll carry the 4 and get 120. So that's going to give me 12 left over. And then bring down the 0. That's going to be 7 times. And 7 times 6 is 42, so that's going to be 11. Now there's going to be 8 left over. Let's give another 0 and see if we can get anywhere with this. 16 is going to go into 85 times. Perfect, because 5 times 16 is an exact 80, so this decimal stops, which is good. So I could just divide the fractional part and then know that the whole number part is going to be part of the answer here. So we're going to end up with 2 and then 0.1875. The fractional part becomes a decimal of 0.1875. So that's going to be the answer. That's one way to do it. Another option, if you don't like that one, which I don't really see the difference between the two, but if you wanted to make this an improper fraction first, remember we could multiply and add, so 16 times 2 is 32. 32 plus 3 would make it 35 over 16. And then if you wanted to take the 16 and divide into 35, it's going to end up being the same thing. I need more space. And let's move all of this. Okay, so we have 35 over 16. Again, then 16 is going to divide into 35. And I'm going to need some decimals. I already know, because I know the answer, right? So it's going to go in twice. That's 32. And then you can see the exact same thing is going to happen from here. So we can get the 2 first and then the 1.875. So we could finish that process if we wanted to. So if you want to take your mixed number, make it an improper fraction, and then divide, you can. If you want to just divide the fraction part and then stick the whole number part in that answer, that works as well. And all of these things could be confirmed with the calculator or Desmos, so no need to panic. Okay, so that's writing fractions as decimals. Next, we're going to compare, okay, fractions and decimals. If we're going to compare, we can use a greater than, a less than, or an equal to symbol to compare. But we can only compare if our fractions and decimals are in the same format. For instance, I could only compare a fraction with another fraction, or it's not precisely true, but it's the easiest way to do it. Okay, if I want to compare a fraction and the decimal, I would either make both fractions or make them both decimals, so that I compare. It's like comparing apples to apples. Okay, so we want them to be in the same format, ideally, to make the comparison. So, for instance, if I was to compare 1/8 and 0.12. Whatever is easier for you. If it's easier for you to make the fraction a decimal and compare decimals, then do it that way. If it's easier for you to make the decimal a fraction and compare fractions, then do it that way. Now, since we're in a decimal unit, I'm going to make these both decimals. So I'm going to take 8 and I'm going to divide it into 1, which is going to need some zeros. So 8's going to go into 10 once. That's going to give me 2 left over. 8's going to go into 20 twice. That's 16 with 4 left over, and then it's going to go into 45 times. So what I'm really comparing here is 0.125 and 0.12, and if I want to, remember I can stick a 0 on that. And so these digits are the same. So remember, we're going to go from the left to the right and look at our digits. So the zeros are the same, don't need to worry there. The 1's the same, we don't need to worry there. The 2's are the same, we don't need to worry there. We go until we find a different digit, and those are different. And whichever one is bigger is our bigger number. So we're going to use a greater than. 0.125 is greater than 0.120. 125 thousandths is more than 120 thousandths. And a similar process here. So let's take our 9/7 and let's make it a decimal. So 9 is going to divide into 7. Let me add some zeros there. 9 will go into 77 times. That's 63. There's going to be 7 left over. And then it's going to go into 70. 7 times, that's 63. There's going to be 7 left over, and you can see that our pattern is going to continue. So really what we have here is 0.7 repeating compared to 0.7 repeating, and those are the same. So the fraction of 7/9 is the decimal 0.7 repeating. So if they're equal, then we will use that symbol to compare them. So inserting that symbol makes a true statement. Inserting an equals makes a true statement there, and then inserting the greater than on number 5 made a true statement there. Okay, so we got to be able to take our fractions and write them as decimals, and we should be able to compare fractions and decimals by putting them in the same format. So that wraps up the unit. If you have any questions, feel free to reach out. Otherwise, I will talk to you guys soon. Take care.